Hello, welcome back. We are going to continue our discussion for chapter 9. So in the previous lecture, we discussed abstract class and interface. Okay. And in this section, we give a brief introduction about ArrayList. And in our previous chapters example, we already use ArrayList. Okay. So for ArrayList, let's compare it with array. Okay. So ordinary array, if you recall, we discussed it in the first chapter. So the size is fixed upon initialization. Okay. And the nice thing for array is it can be indexed. So you can access element very fast through indexing. Okay. And it can store both primitive and reference type. And array itself is reference type. Okay. But array type can be primitive and a reference. ArrayList it belongs to Java collections framework, and the size is not fixed, so it can dynamic grow and shrink, and it supports indexing. Okay, and it only be allowed to use reference type. If for the primitive integer is it, and if you want to use ArrayList, then you got to use the wrapper integer class. So that's a quick comparison between array and ArrayList, and we will see in our examples. Okay. Okay, and for interface, we previously already explained. So it basically is an umbrella type that holds a set of methods. You group some related method together under one umbrella type. Okay, and normally it contains abstract methods. That's the major parts for interface. Okay, of course, it also supports static and default methods. And some constants. Okay. And there are three very important predefined Java interfaces, okay, that used a lot. So let's take a look. The first one is clonable interface. If you recall previously, we, in our design for different classes, we kept implement, override the clone method, if you recall. And that clone method is from object root class. That's a super class of all Java class, okay? And we override it with the own version, is it? And generally speaking, it should provide a deep copy of the reference type, okay? So then what's the relationship between clonable interface and this clone method? Is that so clonable interface basically it's called a marker interface. Be careful, okay? It's marker interface. So what this means basically it does not contain any method or constant. So it's kind of like an empty web, okay? So this interface. So then what's the purpose to have this interface? It's marker interface. The purpose is just to highlight specific traits of the objects. So if you design a class, that class implement this marker interface, that's just to try to highlight some specific traits of that category of objects, okay? So if a class implements the clonable marker interface, generally speaking, you override the clone method from object superclass. Okay, so that's kind of the relationship between clonable and the clone method. Clone method itself doesn't belong to clonable interface. Okay, this method itself comes from object class. So be careful about this concept. So keep that in mind. Clonable interface is a marker interface. There is no implementation, and it doesn't have any method or constants. Okay, and the clone method comes from object superclass. Okay, so generally speaking, if your class implements clonable interface, okay, generally you need to override the clone method. So when we override clone method, the best practice is we implement as deep copy. Okay, so that's why it shouldn't equal, because this is for shallow copy. And also the get class, so the dynamic class should be the same. Okay, so if you recall, this is similar as that equals method. Okay, so the dynamic class be the same. And sometimes we see sometimes it's true, okay, the dot clone and the dot equal. Okay, so the dot clones and equals structurally equal. So sometimes, not always, okay, because later on we will learn the hash code. And so there is attention that we need to be, we need to pay attention, okay, need to pay. So for primitive or immutable reference type, we just return the copy of the value, okay? But for mutable reference type, we need to return deep copy. So be careful, deep copy. And visibility, it can be protected or public. So that's the best practice, okay, for the implementation of the clonable interface to override the clone method. And then for the comparable method, comparable interface, it's another one, okay? Because this equal, it's compare, it's a shallow copy compare. Comparison, okay, basically it's a compare reference. So if you want to compare two reference type for the deep copy comparison, okay, and we cannot use this equal, greater, or less than those operator, okay, those operator are for shallow copy. Not for this equal for shallow copy. I got that. What I mean is here, the comparison is for those generally for value comparison. Okay, value comparison. And for value comparison, we use those sign. And for reference type, then we cannot directly go ahead to use this equal, greater or less than, because equal can cause the shallow copy comparison, and greater they are for value, etc. So then in Java, there's an interface called comparable interface. So for reference type, then we do need to provide this comparable interface for the comparison. of this equal, less than, or greater than, okay, to standardize the comparator for reference type in Java, okay. So in this interface, this is a generic one, okay, till later on we will learn, okay. And it has one method. So this is the abstract method that's not implemented. And it only has this single abstract. So this interface has only one abstract method. We call it single abstract method, SAM. Okay. So if an interface has only one abstract method, so has the property of SAM, then this kind of interface, we call it a functional interface. Okay, it's very useful, okay, for this term functional interface. Also keep this in mind. So comparable interface is a functional interface. And a clonable, if you recall, it's a marker interface. That means it doesn't have any method. Okay, you don't need to implement any method if you implement that interface. And in the comparable interface, we need to override this specific compare to method. Okay, so the compare to method, then we need to take care of greater than, less than, okay, and also equal, those, because it's try to mimic the comparison signs, okay. So if object 1 compare with object 2 greater than 0, then the reverse is true, okay. So same thing for this, you need to maintain. And also if object 1 and object 2 you compare equal to 0, then generally speaking, strongly recommend both structure equality should also be true, okay. And so object 1, so you compare with object 2, returns an integer, okay. So if object 1 less than object 2, then you return negative, okay. So we don't have this comparison sign, but if it return negative, that means it is less than. If it's 0, that means both are structurally equal, okay. And if it is positive, then means object 1 greater than object 2, okay. And for this comparable interface, when class implements comparable interface, we said the class have a, be careful, this keyword, nature ordering. Okay, natural ordering. So it's to follow natural ordering. So natural ordering is some particular way of ordering items. So there is some particular, so you define a specific rule, basically. A specific rule, okay, from the list to the greatest. Okay, so later on in our example, you will have better understanding about this. So keep that in mind. A comparable interface is a functional interface. At the same time, it follows the rule of natural ordering. There is another Java interface. It's comparator interface. Okay, so so for the comparator interface, different from comparable. Okay, it's also a functional interface. It only has one method you need to implement. Okay, and but this time, okay, let's see. Reference type object with multiple member fields, we need to have flexible comparison rule. Okay, so for comparable interface, it's natural ordering. Natural ordering means a specific rule from list to the greatest. Okay, but if the reference object has multiple member fields, okay, not just single one, and sometimes you want to your comparison rule follow one instance variable, sometimes you may want to follow the other, as it give more flexibility. So provide more option for how we compare them. Okay. Then comparable interface cannot achieve that. Okay. So then in this case, you can use comparator interface. So comparator interface, it support, we call it a total ordering comparison. So it's not natural, it's total ordering comparison. So keep that, it's a total ordering, okay. And also class that implement a comparator, they are standalone classes. That's just to define the rule for comparing other classes. Okay, it's different like comparable interface goes with that class. So the comparator interface, a class implement, then it's a standalone class. Okay, we will see that in our example. Okay, and the key difference is its support to total ordering. So it provides more flexibility to do comparison using different set of rules. Not like a natural ordering, just one specific rule. Okay. Okay, and then the answer, if you recall, for the national park that we discussed in this chapter about that gigantic tree and is 1,500 years old. So that tree comes from the Redwood National Park. Okay, and it's a pretty cool national park. Okay, so that's of the concept parts for this chapter, and we are going to discuss the examples for this chapter in our next lecture. See you. Bye.